In Dresden, textile engineering has a long-standing tradition. In 2025, the Technical University of Dresden will celebrate 160 years of textile research and education and the 100th anniversary of the Institute of Textile Machinery and High Performance Material Technology, or ITM for short. As the world's oldest university institute in this field, ITM is a globally recognized innovation and education center with an outstanding reputation. Research spans from the molecule to the finished product, from concept to industrial application. The Institute offers interdisciplinary solutions for lightweight construction in the automotive and aerospace industries, civil engineering, and textile architecture, as well as in biomedical technology, battery research, circular economy, and recycling. ITM, an innovative center with a vision for the future and a fascinating past. In 1865, for the first time in Germany, the university begins scientific research and education in the field of textile engineering under the leadership of Professor Ernst Hartig.
Professor Hartig was revered as the leading expert in mechanical technologies in Germany during his time. These technologies included textile engineering, paper manufacturing, processing technology, food technology, and even construction engineering. As a polymath, he mastered all of these areas, but focused particularly on textile technology.
Teaching color chemistry and textile finishing as part of textile engineering was a revolutionary approach at the end of the 19th century. Today, the world's largest collection of dyes and textile samples is housed in the Königbau in Dresden. In the first decade of the 20th century, the new university campus was constructed, including the Zoyne building, which remains the main building of the Faculty of Mechanical Science and Engineering to this day. Professor Ernst Müller made history as the architect and pioneer behind the Institute's foundation. Thanks to his influence on the Saxon government, the decision to construct the Textile Machinery Hall was made in 1925, marking the establishment of Germany's first university institute for textile and paper engineering. The highlights of Dresden's textile science in the 2 decades following the Institute's foundation include leading advancements in fiber research and fiber analysis. In particular, the scientists from Dresden made significant contributions to the development of viscose fiber.
Professor Paul August Koch
At the beginning of the 1940s, Professor Paul August Koch began his scientific work in the field of synthetic chemical fibers. He also worked on the development and application of glass fibers for technical textiles.
During the air raids of World War II, large parts of the university were destroyed and had to be rebuilt after the war. Professor Walter Franzl took over the Institute's leadership, and 3 years later, he established the Academy Institute for Fiber Technology, now the Leibniz Institute for Polymer Research in Dresden.
The institutes share common roots. At that time, efforts were made to cover a broad spectrum, ranging from fundamental fiber technology research to highly application-oriented endeavors, ensuring the transfer of knowledge into production facilities in the surrounding area.
In the 1950s, Professor Wolfgang Bobeth continued to expand research and education at the Institute.
It's certain that the establishment of research institutes during such challenging times would have been unimaginable without the extraordinary individual contributions of these mentioned figures. The establishment of chemical fiber and glass fiber plants would have been inconceivable without Dresden's contributions. I'm specifically thinking about the many well-trained graduates and the continuous research support during the establishment of these facilities. This is Professor Bobbitt's main achievement.
Research on chemical fibers and advancements in textile technology under Professor Perner provided essential impetus for the design of textile machinery. Innovative gearbox developments by Professor Lichtenheld led to performance increases many times over in the subsequent 20 years. A forward-thinking decision was the introduction of a professorship for garment technology, which was led by Professor Nessler. By 1990, the institute and university faced a turning point. Professor Offerman, a director of the institute and the first deputy rector of TU Dresden, guided ITM through the turbulent years following German reunification.
Yes, we were fortunate that the evaluation by the German Council of Science and Humanities allowed us, as the oldest institute, to continue operating and not be dismantled. The main argument was that our research profile from the 1980s was forward-looking enough to be considered important for all of Germany. It's safe to say that all members of the university were extraordinarily motivated in the years after 1990. The sense of unity, particularly in the engineering faculties, was incredible. The atmosphere was, we can do it, definitely. That's how it was.
The Professorship for Garment Technology was re-established as modern assembly technology for textile products under Professor Rudel. Teaching and research at Dresden gained international recognition. By the 1990s, students and young researchers from over 30 countries were already shaping the Institute's environment. In 1991, the Scientific Advisory Board was established, the first of its kind in the new federal states.
Professor Offerman called me and asked if I would be willing to assist in establishing a scientific advisory board and if I would run for the position of chairman. Of course, I was willing and excited. For me, it was also a personal contribution to the reunification of Germany.
Under the leadership of Professor Shokri Sharif, ITM evolved into its current orientation.
To conduct cutting-edge research, it was necessary to combine machine development, technology, and chemistry. Therefore, we decided to rename the institute from Textile and Clothing Technology to Textile Machinery and High-Performance Material Technology.
Today, ITM is a globally leading university research institution and one of the most successful institutes at the Excellence University of Dresden.
ITM holds great significance for our faculty. It has strong national and international collaborations with other research institutions and industry partners. In material development, sustainability, and digitalization, ITM excels in cutting-edge research. Our vision is to achieve research leadership. This is only possible if we consistently pursue innovation with high economic relevance.
For its innovations, ITM is regularly recognized both nationally and internationally, and is valued as an important partner by the industry.
The connection between textiles and machinery is best exemplified here at ITM, better than at any other institute I know. At ITM, textile machinery is used as experimental material. The machines are tuned and adapted to perform tasks beyond the original design, which is incredibly enriching for us.
This close collaboration with industry benefits ITM students as well.
Just a few days ago, Professor Sharif visited us with a delegation and introduced some young students eager to intern with us. This is exactly the type of collaboration we envision. I believe students graduating from ITM have excellent job prospects on the market.
A combination of cutting-edge research and practical education attracts young talent from around the globe.
I hope the innovative potential of textile engineering will gain greater public recognition, both nationally and internationally. This includes launching international study programs.
Currently, hundreds of master's and diploma students benefit from state-of-the-art research and educational infrastructure.
ITM is among the most well-renowned universities for textile in the world, and the professors here are well-renowned and they have the expertise in their field, and I wanted to learn from them.
During the hands-on training sessions, you get to know all of the machines, first theoretically, and then you get to see the machines in action. It's actually pretty cool because you can directly see what you've learned, and it helps you understand it much better.
Processing high-performance fibers requires highly automated AI-supported machinery that accounts for material properties across processes.
We have a unique machinery park, and it's especially important to us that we use industrial-grade machines. This ensures direct transferability to industrial applications.
With a highly qualified, interdisciplinary team and diverse machinery, ITM successfully tackles the challenges of fiber and textile development.
At ITM, we have all textile technologies: weaving, warp knitting, weft knitting, braiding, multi-axial fabric technology, and tailored fiber placement technology. One of our focuses is weaving technology. Here, we work with a variety of modern machines, including those equipped with jacquard technology and integrated robotics. This allows us to develop new solutions combining innovative fiber materials for diverse applications.
ITM has become one of the leading institutes for chemical, biomaterials, glass, and carbon fiber research.
Our research group focuses on two areas: textile chemistry and finishings, and polymer fiber technology. This involves primarily fundamental research. In polymer fiber technology, we create various materials called monofilaments, which we examine for specific properties. Once parameters align, we can produce them on an industrial scale using large machines. These materials can be applied in virtually any industry, from automotive to medical to fashion. There are no limits to their potential applications. Our research groups collaborate closely, with each member contributing their unique expertise.
A key research focus at ITM is bio and medical textiles, fostering a strong interdisciplinary connection between medicine, biology, biophysics, and engineering.
What excites us is that we now have a highly international team. My colleagues come from various countries, enriching our research and daily work.
Research in biomedical engineering is a cutting-edge field with significant societal relevance.
We've been conducting research in this area for over 15 years. The ability of textiles to mimic human tissue according to biomimetic and bionic principles makes them indispensable in medicine.
With its research, ITM aspires to revolutionize biomedical engineering.
Our vision at ITM is to invent advanced technologies to develop new materials and create biomimetically inspired, degradable structures capable of replicating human organs. This would indeed revolutionize biomedical engineering, and we firmly believe that we can make a significant contribution here.
Another core area of ITM focuses on fiber-reinforced plastics and textile construction with high resource efficiency. ITM utilizes the innovative material carbon fiber for these advancements.
Our main work involves developing new reinforcement structures for the award-winning carbon concrete composites. This material is used in sustainable construction, reducing concrete usage by up to 80%. Although this topic has been researched for a long time, new ideas keep emerging, not only from our side, but also from the industry. This material has firmly established itself, which motivates us greatly.
Multi-physical stimulation calculations accompany product and process innovations, making development processes highly efficient.
In practice, constructions are often required that cannot be realized with conventional technologies. This is where we incorporate robotics. Given the immense complexity, we also focus on material and process models, enabling these structures to be created with maximum efficiency and minimum resources.
The modern infrastructure of the Department for Development and Assembly of Textile Products includes a high-speed 4D scanner. This scanner can capture the entire body in motion, allowing for precise analysis of interactions between body and textile.
I find the field of digital clothing development incredibly exciting. It's about creating individualized clothing and enabling virtual try-ons, which could significantly reduce returns from online orders.
Scientists from various disciplines collaborate to create innovative solutions for the economy and society.
Our Department for Development and Assembly of Textile Products is unique in Germany. We take textiles and turn them into final products. We're like a big family, and it's inspiring to see young researchers so motivated in their fields. We're proud that the best graduates stay with us, pursue doctorates, win awards, and later embark on successful careers.
The Institute not only addresses current economic challenges, but also creates innovations for the textile industry.
ITM is a crucial partner for us, especially in collaboration with companies in the German textile and apparel industry. The biggest advantage for these companies is that research quickly turns into tangible products on the market. Essentially, everything ITM works on becomes a success story due to the outstanding scientific achievements of its staff.
In Dresden, the focus is on developing intelligent production technologies to address global issues.
Smart textiles can transmit human emotions through modern communication systems. For instance, a nurse could assess a patient's condition with data transmitted in real time to doctors. This allows for precise decision-making and tailored treatments.
Research at ITM also addresses environmental protection, circular economy, sustainability, and recycling.
And what we're doing, we're trying to use this recycled carbon fiber in high-performance composites. And we have developed different fiber structures and developed composites with high performance for high-performance applications. I think in this way we can contribute significantly for the environmental protection and sustainable use of carbon fiber for a better world.
The Institute of Textile Machinery and High-Performance Material Technology at the Technical University of Dresden is today an internationally recognized leader in research and innovation. At its 100th anniversary, ITM can look back on a rich history and boldly move forward with visionary ideas into the future.
With these innovations, we are creating entirely new economic sectors, production methods, and product possibilities. ITM is providing us with the perspective for a promising future for Saxony as an economic hub. I am confident that the collaboration between ITM and the Leibniz Institute for Polymer Research will continue to provide crucial momentum in the future. Absolutely, keep it up, because ITM is already performing outstandingly at the highest level. The challenge is to sustain this quality over the next 100 years. I hope that this history continues. The Institute's success has always been marked by the teamwork of all its members. I sincerely hope that ITM will remain at the forefront of scientific advancements in our disciplines. We look forward to welcoming talented researchers who bring their ideas to Dresden. Here, they will find the perfect environment to develop their innovations. We can truly be proud to have ITM here in Saxony.